Unit 18, part 14. All right, what does the conclusion say? It says, there exists a y such that all f's g y. There is some one such that all f's g y. There exists a y such that for all x, if f is x, then x g is y. There is some one. Okay, start with the leftmost quantifier. Right. This is an existential statement. So in general, that means it's saying this whole thing, this formula, is true of one of the ones that are. One of one amongst the things that are. We're in a domain of two individuals, so that's only A and B. So this says this is true of A, or this is true of B. So first step will give us, and the first step, getting rid of the leftmost quantifier, because the leftmost quantifier determines the form of the formula, as was excuse me, stressed earlier, in an earlier chapter. The resulting form will be a disjunction, right? And that will remain its form. This is an existential statement. The first translation, which will leave this quantifier in place, will be a disjunction, and it will remain a disjunction even when we get rid of that quantifier, because that statement will be a subformula of the disjunction. Okay, so see how that goes. So that's sort of the rule. You have to make sure when you do your manipulations, that you sort of stick by that. If the thing is an existential, it should result in the end in a disjunction. If the thing is a universal, it should result in a conjunction, not only after the first step, but at the end, after the final step. Okay, so this is true of A or this is true of B. So either, now all this, so for all x, fx, right? Okay, so we'll also be careful of this, right? The y is here. This is the quantifier we're getting rid of. This is the variable we're getting rid of. Right? This y. There exists some y. So this is turning now into either A or B. And there won't be any more y's. But what? It's the y, not here, not here, not here, but here. Right? So it's only this that gets translated to A and B. Right? The second position of the G. As I said it, there is some y such that all f's g y. So the y is the receiver of the g'ing, as it were. Right? It's in the second place. So this is still fx, hook g, x. Now we get the A. Okay? And what is a disjunction? So that or, major operator of the thing, for all x, fx, hook g, x, what? Yeah, B. Right? There is something that all f's g. So it's either true of A, it's either true of A that all f's g A, or it's true of B that all f's g B. Okay, and now we have, okay, so it's a disjunction, it remains a disjunction. The major operator over here, this will go there. Here. Okay, so now what am I expanding? I'm expanding the quantifier formulas, leaving their overall place in the overall form in the same place. So this quantifier formula is the left disjunct. I'm now just translating the left disjunct, keeping it the left disjunct, keeping the overall form in place. Okay, so what does it say? All f's, for all x, if x is f, then x g is a. So universals go to conjunctions, so it's true of A, that if A is an F, then A G's itself, and, sorry. So that's true, and what? And it's true of B, if FB, then G, B, A, right? The A stays in the second position both times, but the X's become B's. X's become B's here, the X's become A's here, right? So there's that together as the left conjunct or, okay, I'm going to get another conjunction. F-A hook G-A-B and, or this and F-B hook G-B-B. See it all? Yeah. Okay. Right, so either both, if A is F, A, G is A, and if B is F, B, G is A, that's great. Or both, if A is F, A, G is B, and if B is F, G, B, G is B for itself. Okay? All right. So process them for meaning. You've got all those atoms, so take note of all the atoms you have and write them down in a table like this. And this is how I want you to present your answer. You've got FA, you've got FB. Okay, let me just work down here. Okay, you've done the translation, so all we have to worry about is this guy and this guy. Okay? That's the final translation of the premise, that's the final translation of the conclusion. So draw a table like this, right? FA, FB, now we've got all the G's. Four G's. G, A, G, A, B, G, B, A, and G, B, B. Right, you can just write these, you should write these all straight down in one box. I'm just doing this so I can fit it on the bib. Alright. This will be my counterexample if I can manage it, right? Truth values. This will be equals what? True or false? True or false? T, so TTT, FFF, whatever it's going to be. Now we go about assigning truth values to the parts in an attempt to what? What are we doing? Trying to find a counterexample, right? So we want all the premises to come out true and the conclusion to come out false. It's only one premise, we just have to make it true. That means what? The major operator has to be true. This is a conjunction. That conjunction has to be true, and this disjunction has to be false. This disjunction has to be false. This conjunction has to be true. Okay? So let's see how we might do it. Okay, we've got to make this disjunction false, right? So we have to make both of the disjuncts false, right? So this has to be false, right? And this has to be false, okay? These are both conjunctions, so we satisfy that requirement. Again, just to know where we are. If we can satisfy the requirement, and we do satisfy the requirement, we have a counterexample. If we can't satisfy that requirement, it's like the case with the modus ponens. If we can't satisfy the requirement, it means, so far as we know, this argument is valid. If we can't satisfy the requirements, right, which in the beginning of this, and we're expanding out that requirement, we're trying to get it down to the atoms. If we can't satisfy that requirement, then we haven't produced a counterexample. We have found out that we can't produce a counterexample in this universe. We might have to move on to a domain of 3 individuals, right, to try and find a counterexample. Okay? It might be the case that the argument is valid. If the argument is valid, we won't be able to satisfy the conditions, right? We won't be able to find assignments of truth values to these atoms that make that true and this false. But let's see if we can. We do satisfy the requirement if we make one of the 2 conjuncts false in both cases. Yes? So let's start here. Let's go and make this guy, the left conjunct, false. Make that false. Good. There's only one way we can do that. We have to have antecedent true, consequent false. Okay, so this is our attempt. FA true, GAA false. Okay, and that means, of course, they have those truth values everywhere. FA true, GAA false doesn't appear over here. And there's no, yeah, FA is true here. We don't have, right, this is FB, we don't have any GAAs here. Okay, that's good. And look, that tells us what this must be. We're now necessitated in our truth value assignment here, if we're going to satisfy the requirements of getting a counterexample in this model universe. Okay, the conjunction has to be true, so this, of course, both conjuncts have to be true. So the hook has to be true. This, right, the left conjunct is a conditional, so is the right conjunct. The conditional has to be true. Look out, we've got T hook F so far, so we've got to make this true, to make the disjunction true. How do we do it? We have to make this true, right? Because otherwise, if that's false, we got T hook F, which makes that false, and the premise would be false, and we wouldn't have a counterexample. Good. GAB is true. It's going to be true, so GAB is true here. That's the other place GAB occurs, right? Only there. Okay, so that means that this is true. That means that this is true. Right? Okay, again, we have to make this conjunction false. We're going to make one of the conjuncts false, so we've got to make this guy false, so it's got to be true, false. Right? So it's got to be FB true and GBB false, right? Which means GBB is false and FB is true. Okay? And again, that necessitates, so a couple of things to note at this point, that necessitates the truth value assignment here, right? Conjunction has to be true, so the conditional has to be true, both conjuncts has to be true. We've got T hook something or F, right? If that was false, it would be true hook F, which would be false, and we wouldn't have made the premise true, and we wouldn't have a counterexample. So we have to make this true, which satisfies that, but that does it. GBA is true, and we can say this is our counterexample, right? So you point to this and say, this assignment of truth values makes the premises true and the conclusion false. We have produced a counterexample in this domain of two individuals. And that's the end of the course.